we can make some generalizations about polynomial functions. If the degree of the polynomial is even, then the end behavior is the same. The maximum number of terms will be one less than the degree. If the degree of the polynomial is odd, the end behavior is opposite. And again, the maximum number of terms is one less than the degree. Let's look at some functions and see what all of this means. Let's examine the function f of x equals 2x plus 2 and the function f of x equals minus x minus 1. These are both polynomials of degree 1. Since the degree is odd, the graph will have opposite end behavior, which we can see. The first graph extends from lower left to upper right, and the second graph extends from upper left to lower right. Since the degree is 1, there are a maximum of 0 turns in the graph, which we can see since straight lines have no turns. Now let's look at the function f of x equals x squared minus 2x minus 3 and the function f of x equals minus x squared minus 2x plus 3. These are polynomials of degree 2. Since the degree is even, the graphs will have same end behavior. The graph of our first polynomial extends from upper left to upper right, exhibiting this same end behavior. The graph of the second polynomial extends from lower left to lower right, again exhibiting the same end behavior. Since the degree is 2, there is a maximum of 1 turn in each graph, which would occur at the vertex. Now let's look at the function f of x equals x cubed minus x squared plus 4x plus 4, and the function f of x equals minus x cubed minus x squared plus 4x plus 4. These are both polynomials of degree 3. Since the degree is odd, the graphs will exhibit an opposite end behavior. The graph of the first polynomial extends from lower left to upper right, and the graph of the second polynomial extends from upper left to lower right. Since the degree is 3, there are a maximum of 2 turns in the graph. Each of these graphs exhibit 2 turns. It is possible that a third degree polynomial would exhibit fewer than 2 turns, but 2 is the maximum. So again, to summarize, if a polynomial has even degree, then it has the same end behavior, as in the graph in the middle. If a polynomial has odd degree, then it has opposite end behavior, as in the first graph and the last graph.